go to Canvas, in the modules, there's a things to do, and under the things to do is this survey. So I will send an email out to remind you guys. There are 2 surveys. One of them is basic information. The other one is anonymous kind of stuff, and it's nothing too crazy, but I'll show you real quick. Yeah, so one of them is just stuff like your name, if you have a nickname, what your pronouns are, last math course you took, blah, 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 blah. And then the other one is anonymous, and again, it's just because I asked stuff like your political party, how much did you spend on your last haircut? I mean, just stuff like, how often do you sleep? I mean, yeah. And again, just if you can, please fill them out. It'll help me out a ton. And I'll send out reminders. And again, like the other one about what's the last math course you took, how long ago did you take it, that helps me analyze if there's any trend amongst all my stats courses. If I notice that people that took the last math course 4 years ago are doing worse, that would be evidence that we can install like a recency prerequisite, which would mean you could retake a course if you took it more than 7 years ago or something. It's the standard number. Anyway, all that crap you don't need to know, I'm sorry. It just helps me. Right? Okay. Yes?
I have a question about the homework.
Yeah.
So, if we're not submitting it online, are we submitting it online?
Hell no.
No? Okay.
Sorry.
Just making sure. That being said, when we do these problems, do we just do them on paper and then hand them to you?
Yes.
Okay, so we don't get like a handout sheet, we do it on
No.
our phone. Okay.
Yeah, just do it on your own paper. I don't care if it's lined or not. Just try to make it so I can read it. I can't be too hypocritical because my handwriting's terrible, but yeah, and then just give it to me beginning of class, end of class, middle of class, whatever the hell. Yeah. I really never want to grade stuff on Canvas ever again. No, thank you.
Appreciate it.
Hell yeah. Okay. So, we are going to get into chapter 1 a little bit. Today's already been really exciting. So, to continue that theme, chapter 1 is all about definitions. Everybody's on their phone. What's up? I understand you're all like, anything's more interesting than this. Okay. What I try to do with the definitions is I try to kind of make, not a story out of it, but just an example of what we would do in statistics. And you guys come in, you already know some of these terms. I know for sure you do. So for example, some terms we might not know are the difference between descriptive, oh my gosh, statistics, and inferential statistics. Descriptive statistics is exactly what it sounds like. If I take all your ages and I make a little bar graph out of them, yes, we've all seen bar graphs, that's descriptive. If I then took the average age and tried to say, I think all Grossmont students have an average age of what I got from you as a sample, that's inferential. I'm inferring something about a population. So the very first stuff we do after we're done with terminology is we do descriptive statistics. We take statistics and we make little graphs out of them, make little box plots out of them, do all that stuff. That's descriptive. Just here's what I see in my sample. In real life, we do that in real life. Is anybody at all paying attention to any politics stuff? Anybody ever look at election stuff? Like polls they take? Like they say 40% are going to vote for this guy and 47% are going to vote for this woman, right? Okay. Does anybody ever notice at the bottom it says plus or minus 3% or something? So they say 42% are going to vote for this, 45% are going to vote against it. And the bottom says plus or minus 3%. Yes? So that is an example of inferential statistics. They took a sample, they called a bunch of people, and then they try to apply it to everybody. Yes? And that's why polls sometimes can be wrong, because the fact that they're basing it on a sample. And that's why you take many polls and you average them all together. Right? Okay, enough. So that's the big breakdown amongst what statistics can be. It can either just be describing what you see or trying to infer something about a larger group from the smaller group you worked with. Okay, I like it. Okay. So first part we're going to do descriptive, second part we'll do inferential. Okay. Use a different. So let's get down to some brass tacks. What do we use statistics for primarily? When I say statistics, what's the first thing that comes to mind?
Just like data, organization.
Data, I love it.
Yeah, organization of data to try and predict.
Where does data come from? Where do I get data from?
Everywhere.
True.
Numbers.
That's what data could be, is numbers. If I wanted to know the average age of students at Grossmont, do we have enough time to talk to every student that goes to Grossmont? Do you want to do that? What would we do then? Since I don't want to talk to everybody, I take a sample. So I have a population that I want to say something about. So a population is a group of things or people that we want to say something about. And yes, this is my handwriting. I'm not doing this on purpose. So it's a group of people or things that we wish to describe. So for example, let's say Grossmont students. So an example of a population would be all Grossmont students. I'm sorry, purple. You're not really cutting it, buddy. Okay. So a key word that often shows up in population is the word all. So for example, if I said, next door, there are Grossmont students in the classroom next door. What do you have in your mind right now? What do you envision? If I just say, Grossmont students are next door, in the classroom next door. What do you see in your mind?
Group of 20-year-olds.
A group of people, right? Just a group. If I said all Grossmont students are in the classroom next door, what's your immediate concern? Are they alive? Holy shit. What? Get in there. Get in there. No.
It's like a prison.
Yes. Okay, good. And that's what's going to happen. No, I'm sorry. Okay. So when I ask you, what is the population, and you say Grossmont students. No, that's wrong. All Grossmont students. Okay. If you say people from Michigan. No, that's wrong. All people from Michigan. So population has got to be the entire group.
What was that you just said? People.
Like if I was saying something about how people in Michigan eat,
Oh, people.
and I say, what's my population? People in Michigan. No, all people in Michigan. That's my population. You guys understand? I want to really clear. Okay. So we have a group we want to say something about. We want to say something about all Grossmont students. We don't have time to talk to every Grossmont student. So then, therefore, we take a sample. And all a sample is a subgroup of the population. Real quick, if I used you, in fact, before I even say that, can somebody give me, what do you want to know about all Grossmont students? Is there anything you want to know? I'm sorry. Yeah.
How many enjoy history?
How many?
Enjoy history?
Oh, okay. So we'll say this. The percentage of Grossmont students who enjoy history, right? Okay. You guys with me? That might not be what you're interested in, but we're going to go with it. Because that's a good thing to know. So I'm going to take a sample. If I ask you guys, if I use you as my sample, is that a good sample to describe Grossmont? Are we saying you're bad people if I say you're not a good sample? No. Why would you not be a good sample?
Because there's not enough of us.
No. Yeah, in this case, maybe. Let's pretend like there's 30 of us.
Because we're describing all of Grossmont students.
Okay, good.
It's little.
So believe it or not, you need fewer people than you think. Yeah. I agree with you though. Obviously, the more people you get in your sample, the more you can trust your results, unless something happens. Why are you a bad sample? Don't worry about the size. Why would you be a bad sample? You can do it.
Because we're taking a math class.
Okay, beautiful. Okay, Why? Why is that a problem?
Well, because ideally your sample should be representative of like the whole population, right?
Ding ding, yes. So what makes something a bad sample is, did you not make room to make sure that it tries to describe the actual whole population? Is it representative? So why are you not necessarily I'm not saying you definitely aren't. I'm just saying I didn't even try to do it. I'm just like, this is what we would call a convenience sample. How convenient is it for me to use you as a sample? Really convenient, because you're right here, right? And if I say, write this down, you're gonna fail, then you're gonna answer the damn question, yeah? So that's really convenient for me. But, like you said, you're all taking a math class. Could that possibly, not does it, could that possibly bias you one way or the other in terms of whether or not you like history? If there's a purely math major, I'm not saying no math majors like history, but isn't it more likely they don't like history than the general population because they more prefer math? Yes? And again, I am not saying they don't like it, but it's probable that they like it less. That fewer of them would like it, yes? So wouldn't that bias the results? What else is it? You take a summer class. Do all Grossman students take summer class? No. You're taking a summer class early in the day, relatively, right? You're taking a stats class. All these things, right? All these things could possibly bias the results. So what would make for a good sample? What would be the ultimate best way to try to pick a sample to make it representative?
Completely random selection.
Completely random. Why would that be better? The real problem with me just taking you guys as a sample, and again, what I just said earlier about summer class, does every Grossman student take a summer class? No. Does every Grossman student take a stats class? No. Does every Grossman student take me? Thank God. That's a lot of homework. Great. You guys with me? So the best sample is one in which every element of the population had a chance to get in the sample. If I use you as my sample, did every element in the population I'm trying to describe have a chance to be in the sample? No, because not everybody has to take stats. Not everybody was going to take a summer class. Does that make sense? So we're going to come back to that in a bit. Okay.
So we need to find a different sample. other
Yes.
than
If we
history
wanted
that
to-
will help include.
If we wanted to feel confident about what we see, I need a sample that I at least gave a chance for it to represent. Is it possible, if I truly randomly select a sample of Grossman students, is it possible that that sample is still bad?
Yes.
Shit, yes. Is the probability of it being bad equal to me just picking you? No. It's much less likely for it to not be representative. Which is why when we base things on samples, for example, if they say 40% are going to vote for this person and 43%, and the bottom says plus or minus 4%, that plus or minus 4 is covering our ass for the fact that it came from a sample. And the sample could be bad. We're actually going to see the math later this semester behind why is it plus or minus 4%. We're actually going to see the math that leads to that number. It's not just we're going, how do you feel about it? I don't know, plus or minus 4. Yeah, you know, it's an actual math that goes into it. I'm sorry, somebody had their hand up.
I did, but I put my hand back down.
Okay. All right. So, an example here. So, random students, that's a good idea. Somebody else have an idea of how we would effectively get a random sample? I'm open. It could be anything. Sign-ups? Okay.
For some people that volunteer.
And see, it's funny because there's something called voluntary response sample, which is bad. Because, again, there's a bias. Somebody who would volunteer, that group has a bias, and it could influence the results of the thing, right? So let me just say, let's say I have a big old sheet of all students at Grossman. I could put them up on the wall and throw darts, yes? And have random people come in, blindfold, and throw darts, yes? And then I would just take those people. Are you with me? Do you agree that would be decently random?
Yeah.
All right, I like it. There are some issues with that, right? Especially if I put some way at the bottom when, the middle is more likely to be hit, yes? So I can kind of do some stuff. But still, that would be better than just, yeah, you guys, right? What's another way? Just, can somebody come up with one more way? Sure.
You could go to the cafeteria and ask every person who walks to the front door
Wow.
or goes to the front door.
Does everyone go to the cafeteria?
No.
No, I'm with you, I'm with you. It's just another way to get a sample, but it still doesn't representative. It still doesn't allow every element to have a chance to get in the sample, correct?
I guess you could, pick, like a maximum number of students from each, course, like
Dude.
5 math students, 5 science, 5 history.
Gotcha. So every course.
Like almost like
yeah.
an intentional random, you know, does that make sense?
Sure, but if we did that right now, our population would actually be all Grossman students taking summer courses, right? Okay, but that's a good idea. That's actually a specific type of sampling that we're going to talk about later. I could take, on my list of all students, I could take every 7th student, right? If I have a random starting place, and then I take every 7th student after that. Yeah, so for example, you guys, if I wanted a sample of you guys, and I randomly started at somebody, you, and then every 3rd person was in my sample, does everybody have an equal chance to get into my sample? Yes. Let me say this again. I start at a random person, and then every 3rd person after that is in my sample. Did everybody have an equal chance to get in my sample? Can you point to the people that did not have a chance?
The ones before,
No, because I started at a random person. Could I have started it? Yeah.
if you would have started first.
So I really want this to make sense. You can't look at the results and say something. Did everybody have a chance? Yes. I could have started at him, or I could have started at him, or I could have started at her. Do you see what I'm saying? But no, and I want you to understand, your point is good, but we fall into that trap. A sample is never going to have everybody in the population, ever. The key is, was there anybody who could not get into my sample? So for example, what's wrong with calling people on the phone to take a sample of people? Yeah, okay. Not everybody has a phone, believe it or not. Some people are going to just not, so it's more like a voluntary response sample, right?
It's a carrier pigeon.
Huh?
It's a carrier pigeon?
A carrier pigeon works, yes, no. Love it. Smoke signals, yeah, it's great. Telepathy. Anyway, you guys kind of see what I'm saying? So you can't say, well, wait a minute, Ted didn't get into the sample. No. Did he have a chance to? What if I took one person from every row in my sample, randomly from every row took a person? Is that a random sample?
Yes.
Did everybody have a chance to get into the sample? Yes. What if I took random rows and took everybody from those rows?
Yeah.
And again, if you think it's not truly random, if you think somebody, you have to be able to point to who couldn't get in, right? You with me? Now, what if I took everybody who's got brown hair?
No.
Is that truly random? Nope, because not everybody has brown hair. Then some people wouldn't have a chance. Okay. I love you guys. So the first thing that you look for in any freaking thing that gives you any statistics at all is, how did you pick your freaking sample? Holy shit. You guys are inundated. You can't escape this. I don't care if you're not looking for news. I know, does anybody get a newspaper? No. You're not, oh, cool, I like it. You're not necessarily looking for news, but doesn't it still find a way to come at you?
Yeah.
Do you guys see stuff about like 78% of people about it? Do you ever think, okay, where the shit did that number come from? Who were you talking to? How did you pick them? What was the team that did this? Do they have, are they getting paid by, like, if Mars Bars Candy Company pays a researcher and the researcher says, well, actually, chocolate is fantastic for you. That could be true, but you can't trust it, right? And not enough people, this is what I desperately want you to come away from this class with, is just an understanding of what to look for. When somebody says, 58% of people think it, who did you talk to? Where did that come from? Show me your data, show me something. Don't just accept it. Yes?
So how about a sample of everyone who has made an ed plan? Because everyone has a chance to, but not everyone does.
Oh, that's an interesting, okay. But then, not everybody will grow in eggplants, is that what you're saying? Therefore, those people,
Eggplant.
yeah.
Is that what you said?
Oh, I'm sorry, I thought you said eggplant.
No, eggplant.
Eggplant.
At Grossman, right?
I got you.
Grossman.
I think that's a requirement at some point, isn't it? Is it? At some point, it's gonna become a requirement. Let's not go there.
Okay.
But no, it's not just, so if I just took everybody who's been to Spain and I go, well, everybody had a chance to go to Spain, right? I'm still gonna exclude people because not everybody's gonna want to, not everybody will be able to, right? You're like, no, you could stow away in the boat, yeah, there's requirements, right? So it's gotta be something immediate that would be letting anybody come in. Not just, well, if you would have done this, you could have been in this one. Because that could bias the results. Yeah. Okay. So an example of a sample, let's go with putting all the names in a hat. Or whatever, right? So something that's gonna have everybody in the population have a chance. So it could be the DART thing, it could be the picking people from every class maybe in the fall or something. So I'm just gonna say names of all Grossmont students in a hat. And we pick, and this is a really big hat, right? And then we just pick like 80 of them or something. You guys with me? Okay. Pick 80. Random. Okay, so our sample is 80 Grossmont students. Okay. I like it. And did everybody have a chance?
Yes.
Yes. Kick ass. Okay. Once we get that, once we pick our sample, so let's say that we're trying to figure out the percentage of Grossmont students who like history. Once we get our sample and we get them all in a room, what are we gonna do? Immediately. We ask them what?
Do you like history?
Beautiful.
If they raise their hand, then
So there is, in statistics, and in fact it's very similar to algebra, the variable. The variable is related to the question you will ask, the question you want answered, right? So in this case, the question I want answered is, are you interested in history? I like it. So the variable is related to the question we want answered. I am in rare form today, by the way. Good Lord. Just push this all the way over. Beep. So in this case, the question I want answered is, I have a person, do you like history? Therefore, the variable would be whether or not somebody likes history. That's the variable. Yes? Simple. Let me put that in blue. So the black is the definition, and the blue is the example. Whether or not. Holy neck. Okay. Whether or not someone likes history. Okay, how are we doing so far? Okay. Now, the reason we call it the variable, why do we call it a variable in algebra? Why do we call it a variable?
unknown.
It's an unknown. And what values could it have?
It varies.
It varies. It could be anything, right? What can X be? It could be almost anything, right? So in statistics, a question I ask could have multiple possible values, correct? What could the answers be? And that's what we call the data. The data are the answers to this question. So in this case, what possible answers could somebody get?
No.
Yes, no, or.
Yes, no, huh?
I would say like yes, no, or somewhat, or some kind of.
Oh, I see. We're gonna make this a hard fast. You're interested, any level, or not interested, yeah? So yes. In this example, yes, no. Only on every other Tuesday, no. You like it? Okay. Sorry, if you can't read something, just ask me. See some of you guys like, okay. So this is kind of nice. We have a group we want to say something about. There ain't no way we're going to talk to all of them. So we take a sample, we try to make it random, we try to make it representative. Then we ask them a question, and we get a bunch of answers. What do we normally, what would I do then in this case? Once I get all my answers. Yes, 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 no, no, yes, no, yes, yes, no, what the hell, no, no.
Organize.
And then do what?
Compare.
Compared to what?
So you compare the answers, like the ratio of yes to no.
So here's the thing. All right, here's the last piece of this. What was it exactly that we wanted to know? I kind of rephrased it a little bit, but
How many people?
the percentage of Grossman students who are interested in history, right? So once I get all my answers, what would I do to calculate that? So let's say my answers are yes, no, yes, yes, no. Let's say those are my answers. I talked to 5 people. What would I do to calculate the percentage who likes history? I can't average words. I can't get the whole population. How many said yes? Out of how many people? So 3 out of 5, 60%, right? So what we just calculated was a statistic.
What about number 5?
I'll come back to it. Don't worry, leave 5 blank. I love it. I love it. You're all like, wait, math boy. Number 5 comes after 4. I'm doing this on purpose because the statistic is immediate. Anything you calculate from a sample is a statistic. I'm making a point out of that. Didn't just go into like snake speak. So statistic is a numerical description of a sample. So in this case, 3 out of 5 equals 60%. 60% of my sample likes history. I like it. So that's got to have an analog. If I'm describing a sample, that's got to have some kind of analog with population, right? So thankfully, the word that means this for population starts with the letter P. That kicks ass. So the parameter is a numerical description of a population. I don't have an example for that because we don't know it. But that's what in statistics, we're trying to get the parameter, we're trying to figure out what it might be. And the best thing we can do most often is to get a sample. So if I took a sample, a random sample of Grossman students, I took 100 of them, and I found an average age of 24, what's our best guess for the average age of all Grossman students? 24. Is that definitely the average age of all Grossman students? I would put money on it not being, yes? And I teach, so I don't have a lot of that. So it means something if I say I'm going to put money on it. You guys with me? But that's the best guess we have, right? So later this semester, we're going to learn about that plus or minus. So maybe we say 24 years, give or take 3 years. And that would sort of cover our ass. We're not really sure. And that's what I love about statistics, and that's what some people hate about it. Statistics is the most honest math. Algebra goes, X is 7. And this is like, give or take, right? And that's freaking real life. Shit. Anyway, sorry. We'll get into that when we hit some other problems. So this is basically the core terminology. And I think most of you guys, you already knew population sample. You knew data for damn sure. Variable you knew, but it's a little bit different. And parameter you might never have heard of it. And of course, statistics is the name of the damn class, right? So most of these you came in knowing. I love it. Okay. Just a little bit more today, and then I'll let us out a little bit early. Don't get used to it. Blah, 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 blah. Okay, yeah, that's it. By the way, these two, do I have a third color? Not really. Too bad. Oh, I got all kinds of colors. Do joy. Just use this one. These two will either, well, most of the time, either be a percentage or an average. That's the two biggies. Later this semester, we'll learn some new statistical stuff that'll be added to that list, but for right now, it's either going to be a percentage or an average. Okay. All right, so everybody got all this, because I'm going to erase it all. Sure. Yeah, you're good. So what I want to do is I want to kind of get into the breakdown of these things here. This is the last thing we'll do today. Are you done with this side here?
Yeah, no, that's it.
Okay. I remember one semester, I had this one girl, every time I start to erase, she'd go, wait! Oh no, and she's, I'm just kidding. Okay. So, when I look at data, actually more, well, let's see, how do I say this? Yeah, sure. I could have quantitative data or qualitative. You can do it. It's like the word banana. It's like, when do you stop it? Okay. Banana. Quantitative, qualitative. Quantitative, what's the root word of that? Quantity. So what kind of data is that referencing? Numerical data. Truly numerical data, right? So this would be, so what do I mean by truly numerical data? Well, jersey number. The number on somebody's jersey. Is that really a number? Is that really, if you subtract two jersey numbers, does the answer you get mean anything? No, so it's not truly numerical. It's just the name, which is what qualitative is. Qualitative is also called categorical, which is just name data. So a jersey number would be qualitative, not quantitative. I love it. Quantitative is almost always some kind of measurement. Not necessarily, but it's something that you can actually do numerical stuff, subtract stuff and things like that. I like it. So if I subtract two people's zip codes, do I get something that means anything? No. One semester I had 3 girls on the basketball team, and I said, if you subtract Michelle's jersey number from Sarah's jersey number, you don't get anything. They're like, oh, we get Barbara. Because it was 17 minus 14 is 3. I'm like, damn it. All right, shit. That was unfortunate. Okay, anyway, I'll never forget that. It was kind of fun. Now, if I can drill down from these two big guys, 4 levels of measurement. So let me just get through these and then we'll head out. I think I'm still on track. Let's see. There's 4 levels of measurement. And as you go up in these, it just keeps adding new things. You'll see what I mean. The most basic level of measurement, believe it or not, we call it a measurement, it's called nominal data. Has anybody ever heard the phrase plume de nom? Anybody like Stephen King novels? Anybody know who Stephen King is?
Yes.
You like Stephen King novels?
Yeah, Paul writer from Maine. And
There you
I
go.
also do enjoy some of his books.
Do you know that when he started writing, he didn't use the name Stephen King?
What do you use?
Richard Bachman. So if you like Stephen King, and you think you've read all of his stuff, look up Richard Bachman. Right? Some really good work is done under that. That was his plume de nom, pen name. Nom, name. This is purely name data. Color of hair, it's just a name. Yes? Type of car you drive, name data. Yes? For some reason, people see this and they think number. No, plume de nom, your name. Right?
Plume de nom?
I'm sorry, it's French. Plume de nom, which is pen name. Yeah.
Isn't the word nomine the word name in Latin?
There you go. So a lot of these words have, well, obviously, a lot of our words in general have roots in Latin. And of course, French has roots in Latin. Every language has roots in Latin. So Latin's just back there going, I got this whole thing.
I was going to say in German, that begins Büchen.
Of course, Germans, they like to use a lot of, just like Finns. My mom's Finnish, and I try to learn some Finnish, and they try to use every letter in the alphabet in every word. It's crazy. Yeah. So nominal is the base level. If I say, you go to, or here, you could fill out an evaluation for me. Jeff did a good job. Strongly agree, neutral, disagree, strongly disagree. Yes? Have you all done that kind of thing? Or you go to a restaurant. Was their service fair, poor, If I gave you a form and said, fill this out, and it said agree, neutral, strongly disagree, strongly agree, wouldn't you go, wait a minute, what the hell, why is this out of order? Yes? You guys see what I'm saying? So, if I add the requirement that there's an order, ordinal data, order, the data must be in a certain order to make full sense. If I say hair color, do I have to list the hair color in a certain order for it to make sense? Shit, no. What about type of car? If I put BMW and then Hyundai, you're going to go, wait a minute, Hyundai first. There's no reason for it. Could I put it in alphabetical order? Yeah. Do I have to? No. When I'm asking you to rank something, we're going to balk a little bit if they're out of order. It's going to feel like they're trying to pull one on us, right? Like, wait a minute. So it's got to be in a certain order. That's what this is. This is data that must be in a certain order. Okay. So, for example, let's see, what's another one? This could be argued a few different ways, but when you go to a deli, anybody ever been to a deli? Or, yeah, and what do you do?
Deli.
Well, let's see. Does DZ do where you pull a number?
Yep.
Okay, good. And the really deli part, not the restaurant part, yeah.
Yeah.
They have you take a number, and then they call your number. Or anybody ever been to the DMV? Ooh, yeah, this is some great times. But believe it or not, we used to all have to stand in lines forever, but so thankfully they did the whole bingo thing, right? I got A14, they say A13, I'm like, yes, and then half an hour later, they're calling H7. Come on, A, what happened to A? Like, sorry, if you've never been there, then you don't understand what I'm saying. Ordinal data, it must be in order to make sense, not can it be put in order, right? These two are qualitative, for the most part. They're qualitative data. It's kind of a loose thing, but mostly they're qualitative data. The next two are going to be quantitative. And I think, yeah, let's do this real quick. And we'll do more of this next time. I'm going to put them both up here because I need to differentiate them. There's interval data and there's ratio data. When I say the word interval, does that mean anything mathematical to anybody?
Like there's limits.
Okay, there's limits. So if I said a certain time interval, that could be from like 10 to 20 seconds or something, right? You with me? Couldn't you tell me how long that interval is? If it was from 10 to 20 seconds, how long is it? What operation do you just do? Subtraction. So interval data is data where subtraction makes sense. So can you subtract two jersey numbers?
You can.
Does the answer mean anything?
No.
So it doesn't make sense. Can you subtract two, for example, I was born in 1972. Does anyone want to say when they were born?
1983.
1983. If I subtract 1983 minus 1972, does the answer tell us anything?
Nope.
Come on.
Only 11 years.
Are you kidding me? Yes, I've been on the earth 11 more years, right? Been roaming the earth 11 more years. Yes?
Yes.
So that would be at least interval data. I say at least for a reason here in a minute. So interval data is data that can be, not just can be, data where subtraction makes sense. Ratio. What do you think of when I say the word ratio? What operation? I know I'm really low here. Let me put this up here. Division, yeah. Ratio is like a fraction, right? And when I say the word ratio, turn my camera back on? I think it is. You think of division. So this is where division makes sense. If I divided 1983 divided by 1972, would I get a number?
You would.
Would that number mean anything? Would that number mean anything? Wouldn't mean shit. Yes? It wouldn't mean a damn thing. Wouldn't mean anything. Ratio data is where division makes sense. Now, if I took our ages, so is anybody in here 25 years old? Out of curiosity? No. Is anybody, huh?
Older.
Is anybody here 20 years old? There we go, okay. I'm 50. If I did do 50 divided by 20, what do I get?
2.5.
2.5. What does that mean? Does that mean something?
You're 2.5 times older.
I'm 2.5 times as old, right? Which I'm just so happy I'm doing this, just to remind myself. But if the numbers go up, that means you're doing things right. Okay. So where division makes sense, so the answer needs to actually physically mean something. Could I take somebody's area, zip code, and divide it by another zip code, would I get a number? I would get a number. Would it mean anything? No. Okay, I think that's enough. That's so enough. Okay. So, we'll do a little bit more with this, trust me. I just wanted to get it all out there for you. We basically, we're just about done with section 1.1, I think. You could totally start section 1.1.
Interval and ratio are
Quantitative, exactly. Because that's where you start doing truly numerical stuff. Subtracting, dividing. Yeah. All right. All right, guys. Thank you. It's good to see you. Hopefully I'll see everybody tomorrow. Let me know if you need to come up and tell me anything or check out something or whatever. Otherwise, I will see you tomorrow.
Should we have any homework to do tomorrow, or should we?
I would say start section 1.1. Yeah. And even start looking ahead. It's all just definitions. So you should be able to kind of like read through some of the sections. Get ahead a little bit right now.
And it's on this webpage under homework.
Yeah, so no, if you go to practice, that's where it starts. Because if you go to homework, it starts at number 42. So the assignment I created for your homework comes from what it says practice and what it says. Okay. It's just the way the book puts things together.